Hi, Chris Clement. I'm Scientific Secretary of ICRP. I apologize for not asking a question, but the panel can react to a comment. I want to say a couple of things about the previous session that I thought were quite good. That's how a Canadian starts with a criticism, by the way. First of all, there were a couple of things I particularly picked out of Dr. Doss's presentation that I appreciated very much and I think are important points. One of which is that we should be looking at the whole person. Obviously, all our studies can't do that. You have to look at mechanisms at much lower levels of, much lower scales. We can't put humans into cages and irradiate them in radiation chambers. So you have to look at mouse models, cell cultures, and so on. But the result is protection of the whole human, not against one kind of cancer or one circumstance. And it's about the protection of all people, not just one person in one circumstance of one age and so on. So that's, I think, a key point, looking at the whole person, and quite interesting results that Dr. Doss showed. The other, it's been raised a couple of times, dose rate matters. It seems that that's probably true. We've seen some preliminary thoughts from Task Group 91. We're in a room, discussed them yesterday, where dose rate seems to make a difference. But I want to look at the bigger picture. So my basic comment is about where we agree. I hope everyone in the room agrees that if you get big doses, you have trouble. You get cancer or worse things happen at big doses. I hope no one disagrees with that. As the doses go down, the risk goes down. I think people agree with that too, generally. How they go down to where they go, that's not agreed. Fair enough. But the way I look at it is that once you get to some level of millisieverts or whatever, results are lost in a seas of uncertainty. We saw the picture that David put up just before at the beginning of this session. You can argue that that shows a threshold. You can argue that that's consistent with LNT. You can argue it's consistent with lots of models. But the point is that data isn't inconsistent with a variety of models. So we don't really know. In addition, there's lots of definitive-looking studies that don't agree with other definitive-looking studies at low doses and low dose rates. And we have to understand that this is where we are. We live in an era where we don't really understand in detail what's going on at low doses and dose rates. How do we get out of it? More research is the scientist's answer, and I don't mind that answer at all, especially looking at low doses and low dose rates. And Julian Preston, actually yesterday, I'm sure he's still in the room, had some good advice on how that might be managed more efficiently. And second, because we as a society and ICRP as part of our mandate have a responsibility to contribute to protection of people, how do we run a system of protection to protect people with this uncertainty at these low doses and dose rates? For me, that's the central question. We're not going to answer what's the risk at 20 millisieverts in this room today or probably in the next 20 years. The opinions will vary for probably longer than I'll be alive. But we have to answer the question of how do we behave with this uncertainty in a responsible fashion. Thank you.
Yeah, I think everyone could agree with that the issue is how we respond to the uncertainty that we have. And it's not an easy question. Please.
Well, in the last half of the 70s, it was decided by government with the DNA and that's the Defense Nuclear Agency, and the DOE to go out and clean up the test area at the Eniwetok Atoll. As we prepared for that and mapped out the radioactivity, we spent years doing that and then launched a major cleanup in 1977. Well, I thought Daryl gave a really good talk earlier today that showed the decrease with radiation protection standards. Well, if the LNT model is the driver of that, I hate it. I hate it for this very reason that I'm about to tell you. We experienced that cleanup, and we killed 6 men doing it. We brought them home in body bags. We had 54 lost time accidents because it was a construction project cleaning up a program that the environmental impact statement for the no-fault condition projected 1 latent cancer in 30 years for a returning population of the Inuitakis of 1,000 people. That was no fault. Well, we went ahead and cleaned up at a ridiculous low level that made it really difficult for us health physicists to measure the radioactivity in the soil. And up until that time, trying to invoke standards at the Nevada test site, I didn't have a lot of problem with the LNT and all of the crap that was coming down the way of regulations, because I could just pass it on to my contractors and sit on their butts and tell them to do the things that they had to do. I thought that was pretty straightforward. And it wasn't until the Inuitak experience that I realized that what we were doing with these very low doses and translated to very low cleanup criteria, we were transferring the risk to real people. We're calculating the risk to mythological people and transferring to real people.
Let me add just a minute to what Dr. Higley and Bruce Church said, because I worked for 10 years on the uranium mill tailings cleanup project, and I did an environmental impact statement, or EIS, for virtually every one of the sites. There were 24 mill sites in 10 states that qualified for cleanup, and we did all that. We spent a couple of billion, $3 billion doing it, and we killed 4 people. They were incidental deaths. It had nothing to do with radiation, of course, and I don't want to say the cleanup didn't need to have happened, but the incidental deaths, we spent $3 billion to kill 4 people. That kind of, it doesn't sound right.
Actually, my comment kind of piggybacks on what you just said. A lot of the criticism I've heard is, well, we are looking at the LNT model versus hormesis or threshold models, but a lot of the criticism I'm hearing is actually not around the model, but it's around a misunderstanding of the Alara concept. People seem to have forgotten the reasonable part of Alara and have gone well beyond what is reasonable into what's actually harmful. So I just want to put that out there that we should separate the scientific endeavors from the, I'm not sure exactly where it comes from, bureaucracy or what, but sometimes where we've gone beyond Alara.
Let me add to that just a brief thing. It's the Alara principle is based on a principle, the Alara principle, and it ought to be the Alara approach. Just like common sense, and when you walk up close to the cliff, you approach the cliff, but you don't, as a matter of principle, stay away from cliffs because they're fun to look over.
Hi, I'm Bruce Napier. You might remember me from yesterday. I have another life other than dose reconstruction, and one of them, one of my alternative lives is dealing with cleanup of old facilities at the Hanford site. If you're from around this area, you realize that there's one of them called the plutonium finishing plant. And as a disclaimer, I'm up to here in the plutonium finishing plant. But I would like to say that last December, there was a contamination event. Some plutonium got spread around. A number of people were exposed. And they shut down basically all demolition projects in the DOE complex for several months, and they're just now restarting here at Hanford. That particular event, they did fecal analysis on 320 people and determined that the total collective dose in the worker population was 29 person millirem. It's cost several $1 million, so the total R in Alara right now is about $2 billion a man-rem. What I would say is that I don't really care about the shape of the curve. The problem, as Roger McClellan brought up yesterday, is implementation. In the Department of Energy regulations, the workers can get 5,000 millirem a year each, and it can be some combination of internal and external. When these people inhaled a little teeny bit of plutonium, the DOE managers back in D.C. went, oh my God, how can we tell these workers that they've inhaled plutonium when we know that a single particle of plutonium in your lungs is a death sentence? We have a problem with implementation of the existing regulations. It's totally out of control. Something needs to be done. I don't have a problem with, 1 millisievert for the public and 50 for the workers, but we're nowhere near that in any case because of the way we apply the existing rules.
Dan Strom, USTUR. We were all very moved by Bruce Church's comments. I haven't heard this room silent for 5 minutes before during this meeting. And he pointed out the downside, the 6 body bags and 54 lost time injuries. There are lots of people who lose their lives and have lost time injuries as lumberjacks. And so I think we need to always think of ICRP's first principle of radiation protection, which is justification. No practice shall be adopted unless it produces a net positive benefit. And so the people who are doing the cleanup at Any We Talk, or the people who die being lumberjacks, get the benefit of a paycheck. And furthermore, they get the benefit of, many of them, maybe not lumberjacks, but many people get health insurance, which is, from a public health standpoint, the most important thing you can do for people's well-being, not worrying about a millisievert here or there, but making sure they have insurance if they do get sick. So I'd like to never just look at body bags without realizing that the workers who were doing that, whether it was necessary or not, were getting a paycheck and maybe they were getting health insurance. And it sounds to me like that was as dangerous as being a lumberjack. But still, let's never forget that people go to work in dangerous professions to get a paycheck and the other benefits that come with a job. So I was really moved by what Bruce said, but those people were also getting some benefit. I don't know if it was really unusually risky, but let's keep that in mind.
I'd like to respond to that. Every time I have told people about that, I always get that comment, well, they got a paycheck, so they were the, and that's true. But these were military young men, and their paycheck wasn't very high. And furthermore, I don't have a problem if they're doing something worthwhile. And I think that comment is probably on target. But when you're doing something that's cleaning up, something that don't need to be cleaned up, then that's baloney. When we put people at risk, it doesn't need to be put at risk because the objective of what you're doing is worthless. Then it is a total transfer of risk and there is no benefit to those employees.